Good morning friends, welcome back to Parnika tutorials. We know that process synchronization mechanisms are broadly classified into two types. One is busy waiting solutions and another one is non-busy waiting solutions. Till now we have discussed several process synchronization mechanisms such as lock variable, turn variable, interest variable, Peterson solution. All these mechanisms comes in the category called busy waiting solutions. There are some issue with the busy waiting solutions. That's why the developers have introduced the non-busy waiting solutions. First, let me give an overview about the busy waiting solution and its limitations. Then I will discuss about the non-busy waiting solutions. Now look at the busy waiting solutions. We know that there will be a critical session. In the critical session, we have to provide the mutual exclusion. The primary requirement of any process synchronization mechanism is to provide the mutual exclusion. What is meant by mutual exclusion? If there are two processes such as P0 and P1, only one process should be there in the critical session at most at any particular instant of time. Let's take that P0 entered into the critical session. Now P1 also wants to enter into the critical session. If P1 wants to enter into the critical session, it will execute the entry session because each synchronization mechanism will have the entry session, then critical session, then exit session. Is it clear? So if process P1 wants to enter into the critical session, first it needs to execute the entry session. When it executes the entry session, as process P0 is there in the critical session, it should not allow the process P1 to enter into the critical session. Whatever the process synchronization mechanism you are designing, if it is providing the mutual exclusion, it will not allow the process P1 to enter into the critical session. So what P1 will do, it will check whether the critical session is vacant or not. If it is vacant, process P1 can enter into the critical session. If it is occupied, then again it will check whether critical session is vacant or not. It will keep on checking this one. Am I right or wrong? So we have discussed several mechanisms. What is happening? There will be a while and some condition. As the condition will be true, again it will keep on checking the condition. So it is keep on checking whether critical session is vacant or not. So it is not doing any other activity. It is keep on checking whether the critical session is vacant or not. Whenever the CPU is scheduled for the running state, it is keep on doing the condition only. So it is not doing any useful task. Is it clear? So these kind of solutions will call it as busy waiting solutions. Now what is the issue with the busy wait solution? This process P1 is not doing any useful task. When the critical session is occupied, it is keep on checking whether critical session is occupied or free. Is it clear? And one more issue with the busy waiting solution is priority inversion problem. Is it clear? Let's take that two processes are there, P0 and P1. Okay, currently process P1 is there in the ready state. Okay, and process P0 has not arrived. Let's consider that this priority of this process P1 is 2. Okay, so process P1 is currently in the running state and it has entered into the critical session. Is it clear? In the critical session, process P1 has entered. Now process P0 has arrived to the ready state and its priority is some 5. Now look at the priority. The priority of P1 is 2 and the priority of P0 is 5. So which one has the highest priority? P0. We know that in the preemptive priority based scheduling mechanism, if a high priority process is there in the ready state, the process which is currently running will be preempted and process P0 will be dispatched to the running state. So process P1 has been preempted. Now if it is preempted, now where the process P1 is there? In the critical session. So P1 is with the critical session. Is it clear? Are you able to understand? It is preempted. Now look at here. Whether critical session is vacant or occupied. It is occupied by P1 because P1 has not completely executed the exit session because For any critical session, if you are designing a process synchronization mechanism, you will have a entry session, critical session, and then exit session. So once the P1 completed the executing of the exit session, then only we can say that critical session is vacant. Right now, process P1 is there in the critical session and it was preempted. Now, process P0 also wants to enter into the critical session. So it will execute the entry session. Now, if your synchronization mechanism providing the mutual exclusion, then P0 cannot enter into the critical session. Is it clear? So what it is doing, it is keep on checking whether critical session is occupied or not. So P0 cannot able to enter the critical session and cannot able to complete its task. You know that in high priority scheduling mechanisms, in the priority scheduling mechanism, if high priority process does not complete its task, then low priority process cannot come into the running state. Am I right or wrong? So process P0 wants to complete the task, but however it is not able to enter into the critical session. Now P1 cannot able to schedule. So what is the issue is that the critical session is with the P1 and then P0 is in the running state. Are you able to understand? So P0 cannot able to complete its task because the critical session is occupied, and P1 is not dispatched to the running state because a high priority process is in the running state. So this issue we will call it as priority inversion problem. This will happen in the busy wait solutions. All the busy wait solutions such as Peterson solution, interest variable and turn variable, all these solutions, this problem is there. Is it clear? So to overcome these problems, one is that a process is keep on checking whether critical session is occupied or not, and another thing is that to overcome this priority inversion problem, the developers has introduced the non-busy waiting solutions. Is it clear? In non-busy waiting solutions, how the thing will work is that, look at here, there is a process P0 and there is a process P1. Is it clear? Let's consider that at a particular instant of time in critical session, process P0 is there. Is it clear? Now P1 wants to enter into the critical session. It will check whether critical session is occupied or not. Now look at here, critical session is occupied or not? Yes, critical session is occupied. Now in non-busy waiting solution, what the process P1 will do is that as the critical session is occupied, I cannot enter into the critical session, then process P1 will go to the sleep state. Is it clear? It will go to the sleep state, meaning is that it is blocked. Are you able to understand it or not? Now, you know that once the process P0 completes its critical session part, then it will execute the exit session. Okay? Once it comes to the exit session, it will check any process is there in the sleep state. If any process is there in the sleep state, it will go and wake up. Is it clear? Are you able to understand? So that process P1 will be wake up and it will check, yes, now critical session is vacant, it will enter into the critical session. It is very simple. Let me give it a real-time example. Let's take that in a home, husband and wife is there. Okay, is it clear? Now husband wants to watch the IPL match. Okay, and wife want to watch the Big Boss. Is it clear? And luckily wife got the remote first. Is it clear? Are you able to understand? And wife is watching the Big Boss. Now husband cannot fight with the wife because he know that if he fight with the wife there is no use. So what he will do, okay, I cannot watch IPL today, it is my bad luck. Okay, hope the Big Boss will complete in next 15 minutes or 20 minutes. So what the intelligent husband will do, he will go and sleep or he will do some other work. Am I right? Because he cannot fight with the wife. So what the husband will do, he is either sleeping or he is doing some other task. Let's consider that in this scenario, husband again went and slept. And then he has kept quiet and wife was completed watching the Big Boss. Is it clear? Then if the wife goes and wake up, yeah, I have completed watching the Big Boss. Now if you want to watch the IPL, you can come and watch. So this is what we will call it as sleep and wake up. Is it clear? So let's consider that process P0 is there in the critical session and P1 wants to enter into the critical session. It will find that critical session is occupied. Once the P1 identifies that critical session is occupied, it will go to the sleep state. Now once the process P0 completes its execution of the critical session, it will wake up the process which is in the sleeping state. Is it clear? Then process P1 come and enter into the critical session. So mutual exclusion is provided and it is a non-busy waiting solution. Is it clear? I hope you have understood the limitations in the busy waiting solutions and how the non-busy waiting solution is working. Now let me discuss one important solution or the process synchronization mechanism related to the non-busy wait solution or sleep and wake up solution. Is it clear? Now let me discuss this one. We will call it as producer consumer problem. Is it clear? Now what the producer will do, he will produce the items. The task of the producer is to produce the items and the task of the consumer is he wants to consume the items. Is it clear? Let me tell with this simple real-time example. As we have taken husband and wife, let's take mother and son now. Okay, now it is a early morning, 8 o'clock. Okay, let's consider that it is 8 a.m. Then obviously we know that everyone will have the breakfast. Let's take that mother today is preparing the dosa. Okay, now what is the mother duty, or mother usually what they will do? They love the son and they will say that I will pour the dosa. Obviously in every home mother will pour the dosa. Is it clear? Even the son knows the cooking, she will not allow the son to cook. Okay, now mother is keep on pouring the dosas. There is a one plate. Okay, now what is the duty of the mother is pouring the dosas, and what is the son duty? To consume the dosas or to eat the dosas. Now let's take that there is a one plate and in that plate only 5 dosas can be there at max. Is it clear? Now look at here. First son will see the plate and the plate is empty. Then what he thinks, okay, mother has not started yet pouring the dosas, let's wait. Or what he will do, instead of waiting, he will go and sleep. Are you able to understand it or not? Let's consider that in this scenario, when the son sees the empty plate, he will go and sleep. Okay, now what the mother will do, mother will pour a dosa. So she poured one dosa. Okay, right now when she poured one dosa, she will go and wake up the son. I have poured one dosa, you, if you want, you can eat it. Is it clear? Are you able to understand? First the thing is that son will check whether dosa is there on the plate or not. If he finds that there is no dosa, he will go and sleep. Now mother will produce one dosa and she will wake up the son. Okay, now let's take that son is keep on eating, and you know that mothers are very talented and they will keep on pour the dosas very fast. Let's take that she poured 5 dosas. Okay, now the plate is full. Then what the mother will do, as the dosas capacity on the particular plate is completed, she will go and sleep. Okay, let my son complete eating the dosas. Okay, now the son has started eating the dosas. There are right now 5 dosas are there in the plate. Now he started eating. Now once he completed eating one dosa, then there will be 4 dosas. Then he will go and wake up the mother. Is it clear? Are you able to understand? When the plate is empty, son will go and sleep. When the plate is full, mother has went to the sleep, and it is duty of each other to wake up other person. Is it clear? When there is one dosa, mother will wake up the son. When there are 4 dosas, son will wake up the mother. Is it clear? So this is the simple producer consumer example. I hope you have understood this with this example. Now let me discuss the concept for you. Now hash define n20. Here I am considering the buffer size as 20. Here we have considered the maximum capacity is 5 doses. So here it is 20. Now you can take the buffer size as much as you want. Now I am taking a global variable called count and I have initialized to 0. Now producer task is to produce the items and consumer task is to consume the items. Now look at here, int item while true. means every time the condition will be true, this task will be keep on doing it. Am I right? You know that it is a condition. If the condition is true, then while statements which are there in the while loop will be executed, and this condition is always true. Is it clear? There is no condition, they have completely given as true. Okay, now item is equal to produce item. Produce item is a one function which will useful for you to produce the items. Okay, now look at here. If count is equal to n, because the buffer is full, am I right? In this case, the 5 doses are the buffer. If count is equal to n, then you have produced n items, because I said count is equal to 0. This is useful for you to know how many items are there in the buffer, and this n is the maximum capacity of the buffer. Okay, so if number of items in the buffer is equal to maximum capacity, then producer has produced all the items. Now it is the task to the consumer to consume. So what the producer will do, he will go to the sleep. Is it clear? Now else, meaning is that if this condition is false, if count is not equal to n, then whatever the item it was produced, he will insert into the buffer, insert underscore item. So it will insert the particular item in the buffer. Okay, and then he has to increment the count value, because the count variable will be useful for you to know how many items are there in the buffer. So as one item is inserted, he has to increment the count value. Now look at here. If count is equal to 1, wake up consumer. We already discussed, when mother poured one dosa, as there is a one dosa in the plate, she has to wake up the son, because she knows that maybe the son would have seen the empty plate and he would have gone to the sleep. Obviously in our home also it will happen. Once the mother pour one dosa, she will say, yeah, I poured one dosa, you come and eat. Am I right or wrong? So similarly, if one item was produced, then it is the duty of the producer to wake up the consumer. This is what the producer will do. So producer is sleeping and also producer is waking the consumer. Okay, now look at what is the consumer task. Int item, while true, if count is equal to 0, if there are no items in the buffer, what the consumer will do? He will go to the sleep. Instead of waiting for the producer to produce some item, he will go and sleep. Okay, item is equal to remove underscore item, meaning is that if count not equal to 0, if this condition is false, then meaning is that there are some items in the buffer. Then what the duty of the consumer is, he has to remove that item from the buffer and he has to decrement the count. Am I right or wrong? Suppose let's take that there are 4 dosas here. Okay, once the son has eaten one dosa, the number of dosas will be 3. Am I right or wrong? So that is what it is doing. If count is equal to n minus 1, meaning is that if count is equal to n, what the producer is doing, he is going for the sleep. Now when the consumer sees count is equal to n minus 1, he thinks that okay, before I consume one item, there are n items in the buffer. So there may be a chance that producer would have went to the sleep. Now there is one empty item, meaning is that n items can be kept. Right now only n minus 1 items are there. So there can be one item can be inserted in the buffer. So producer can produce. So what the consumer is doing, he is wake upping the producer. Is it clear? Now obviously he will consume the item. Obviously you will eat the dosa. Am I right or wrong? Is it clear? So this is what is actually happening in the producer and consumer. Now let me discuss the issue in the producer and consumer problem. Is it clear? I hope you have got the thing. Now let me discuss what is the issue in this one. Okay, now look at here. What is happening if count is equal to 0? Okay, it is going for the sleep. Now let's take that. Again we'll take the same example, mother and son. This is a beautiful example always. Mother is there and son is there. Okay, now mother's duty is pouring the dosas and son duty is to eat the dosa. Now son has seen the empty plate. Then what the son will do? He will go for the sleep. Am I right or wrong? So similarly here, if count is equal to 0, meaning is that the buffer is empty. If the buffer is empty, what the consumer can do? He cannot consume the item. So what is the task he has to do? He has to go to the sleep. Now when he was supposed to go to the sleep, when the consumer was about to go to the sleep, it was preempted. Is it clear? So similarly here, when the son saw the empty plate, what he will do in our example, he will go to the sleep. When he was about to go to the sleep, someone has called him in the phone. So obviously he will go to the balcony and he will speak. Am I right or wrong? Is it clear? So in this task, when the son has seen, he was about to sleep, but he got a phone call and he was keep on talking. So similarly, now look at here. The mother has poured one dosa. Is it clear? Now what is the task of the mother? Once she poured one dosa, what she will do? She will go and wake up the son. Am I right? Is it clear? Are you able to understand? If count is equal to 1, wake up consumer. Okay. So now let's take that. She knows that son will sleep in one room. Okay. In that house, there is one room, separate room for the son. So she knows that son will always sleep in that room. So what the mother has done? She has knocked the door. Am I right? That is the signal to wake up the son. But whether son is there in this room? No. He is in the balcony and he is speaking with someone. Are you able to understand it or not? So what mother will think? I have wake up my son, and she will keep on pouring the dosa. Suppose let's take that son did not came because son was waiting, and then look, let's take it. Now son has completed talking the phone. Are you able to understand? Let's take that we started preparing the dosas at 8 o'clock. Now let's take that 8:85. Mother has knocked the door. Whether son is there inside, son is not there. And now at 8:07, son has completed talking the phone. Then now he has gone for the sleep. He thinks that okay, mother has not still completed preparing the dosas, so he will go and sleep. Once the mother pour dosa, she will wake up. At 8:07, son went to the sleep. But at 8:05, mother has knocked the door. So mother duty is completed. She has to wake up the consumer. She has waked up. Now what the mother will do? She will pour all the dosas. Let's take that. By at 8:10, mother has poured all the 5 dosas. Then what the mother will do? She will think that okay, my son is doing something, or he is very slow in eating. Okay. And what she will do, once the capacity is full, she will go and sleep. Now at 8:10, mother went and slept in her room, and she is thinking that okay, when my son completed eating one dosa, he will wake up. And son is thinking that once my mother pour one dosa, she will wake up. Now both are sleeping. Now what is happening? Sleeping is here what? They both are there in the wait state. Am I right? Now if both the process are there in the wait state, what is this scenario? This is what? Deadlock. Am I right or wrong? So in producer consumer problem, we will have a deadlock. Let me discuss with this thing. Now count is equal to 0. When the consumer was about to go to the sleep, it was preempted. Okay. Are you able to understand? And producer has produced one item. So count is equal to 1. What he is doing? He is wake upping the consumer. But the consumer is not there. Are you able to understand? It was preempted, and the producer has given the wake up signal, but that wake up signal has not reached the consumer because the consumer is not sleeping. Once the wake up signal is completed, if the consumer has went for the sleep, now what the producer will think? I have waked up the consumer. It is the task now for the consumer to consume the items, and producer will keep on producing the items. If count is equal to n, because the consumer is not consuming the items, so and the producer is keep on producing the items, then what will happen? Count value will reach to the buffer maximum capacity. When count is equal to n, producer went to the sleep. Now consumer is in the sleep state, producer is also in the sleep state. What is meant by sleep state is nothing but the waited state or the blocked state. Am I right or wrong? So now both the processes are there in the waiting state. Is it clear? So which is nothing but a deadlock. I hope you have understood what is a non-busy waiting solutions, what is a producer and consumer problem, and what is the issue with this one. And this problem can be overcome with the help of one variable called semaphore. Now what is the actual issue is happening? The producer is doing its duty and consumer is also doing its duty. Am I right or wrong? Consumer task is to go and sleep when the count value is equal to 0. Now what is actually happening? When the wake up signal was generated, consumer was not sleeping at that time. After that it is sleeping. So this wake up signal is wasted. Because of this one, entire deadlock issue came. Am I right? Now let's take that what is the solution we can do is that wake up solution, what it is doing is that, let's take that we are taking one variable. Let's take it. Okay, in that variable, if I am keeping the number of wake up signals, let's take that producer has produced one item. Okay, now he has to wake up the consumer. Instead of waking up, if he keep one count, where count is equal to 1, or some variable is equal to 1, which represents that number of wake up signals it has generated. Now before the consumer goes to the sleep, he has to look at this variable. Are you able to understand? If this variable having the value other than 0, means it is greater than 0, meaning is that now right now it is having 1. So meaning is that one wake up signal was generated by the producer. Then meaning is that there are some items, so he will not go and sleep. Are you able to understand it or not? So instead of waking up the consumer directly, it is keeping the count in some variable. Now it is the task of the consumer before going to the sleep, he has to look at this variable. Are you able to understand? And this variable is we'll call it as semaphore. Is it clear? In the next video, we will discuss what is a semaphore and what are the different types of semaphores are there. If you still have any doubts related to this concept, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.